Our context is the growing interest in the standardization of processing pipelines, and this is crossing roads with some relevant international initiatives. These include multimodal imaging that is focused on structural and functional features mapped onto the cortex that are a more complete and precise characterization of all brain states. This is specifically with inclusion of high spatial resolution imaging like histology that is based on the big brain, and the registration with high temporal resolution techniques like MEG and EEG that is mapped on the source space. The Human Connectome Project have introduced standards, requirements, and protocols for mapping in vivo structural imaging as well as MEG and EEG. In this case, we have produced the registration of the big brain onto the ACP structural space, which we base upon an hybrid image of the big brain and ICBM MRI template that is weighted in T1 contrast. With this registration, it is then possible to obtain the concurrent mapping of any structural and functional feature onto the individual ACP and big brain spaces. We show an example of MEG-EEG source imaging that is practiced onto the individual big brain space using ACP, MEG, and BC Vareta pipelines, and then source imaging from both is mapped across all spaces. There is no other software that carries out this functionality. A strategy has been projected to inform subject-specific neural models. This will reveal the true space of parameters describing brain states. The steps for this are: A. Define a neural model with cortical layers and columnar connectivity that are obtained from the big brain. The model is then informed by sources head and lead fields defined from the ACP MEG pipeline and then BC Vareta source imaging and connectivity. Discovery of the parameters can be expanding neural equations and inferring them from BC Vareta results. Then these results are mapped across all spaces, individual, ACP, and big brain.